My name is Rachel Hendrix, and today we're going to look at agricultural educators' levels of personal teaching efficacy towards STEM education. We know that there have been pushes for increased STEM integration across all areas of education since the 1990s, and Ag Ed is definitely no exception. However, there are some challenges that STEM integration currently faces, and that includes teachers who are unprepared to teach certain subjects or who are unprepared to teach more rigorous and more difficult material. Teachers may also be unaware of the underlying principles that guide STEM education and different STEM education methods that are recommended. Finally, they may not know how to get students interested in STEM subjects, all of which can be a problem. If we are going to face some of these challenges, we need to understand how teachers approach STEM education. And so this may look at the context through which they view STEM, the methods that they use, the subject choices that they make, and how they run their classroom environment. We chose to use Bandura's social cognitive theory for this study, which says that environment, behavior, and personal characteristics all interact with one another. Self-efficacy is considered to be a personal characteristic, and that is a person's confidence in their ability to achieve a desired outcome. And it affects many different things in our everyday lives. Teacher self-efficacy in the same way can affect a teacher's classroom performance, behavior management, enthusiasm, motivation, all of which are considered to be factors that successful teachers are able to demonstrate when they are in the classroom. Teacher self-efficacy has two types: personal teaching efficacy, which is the teacher's confidence in their ability to teach something or to work with a certain student, and then outcome expectancy, which involves itself with a teacher's view of their ability to influence something that is ultimately beyond their control. Situation with teacher self-efficacy is very important, as is subject, because these factors can influence a teacher's efficacy. So for example, a teacher might feel more confident when they teach science versus when they teach English or when they teach math. In Ag Ed, we may feel more confident when we teach animal science or plant science versus agricultural mechanics or agricultural economics. For this survey, we contacted 447 agriculture teachers in Mississippi and Tennessee. We got 91 responses, which gave us a 20% response rate, and we sent this instrument out through Qualtrics. We did use a pilot test of Alabama agricultural educators. We used the T-STEM survey instrument, which was developed by the Friday Institute at North Carolina State. We chose to use the STEM instructor portion. There were several different parts of this survey, but we chose the one that was most pertinent to our study needs. This portion gave participants 11 statements that were ranked on a Likert type scale that ranged from 1 to 5. 1 was strongly disagree, 5 was strongly agree, which gave us a total of 55. There are 2 sample statements here, and what we did was we had teachers fill in the blank. So I am continually improving my science teaching practices, and then they would do it for technology, and then engineering, and then math. They did this for each of the 11 statements. We also had them give us some demographic information, which included the number of STEM courses that they had taken. When we take a look at the results here, we find that science was where teachers had the most confidence. It had the highest overall mean and the lowest overall standard deviation. They also had completed a total of 699 post-secondary courses, which is a lot. When we look at the statements individually, we find that there is a strong focus on the teacher's confidence in the subject matter and their ability to teach it, and also in their ability to answer students' questions. With technology, we find that they were still pretty efficacious and confident in their ability to teach it. It had the second highest mean and the second lowest standard deviation. They completed 161 post-secondary courses, and just like with science, it focused mostly on their personal confidence in the subject and their personal confidence in their ability to teach it. When we take a look at mathematics, we find that teachers were a little less confident about their ability to teach this subject, even though we had 252 post-secondary courses reported. It did have the third highest overall mean, and it had the third lowest standard deviation. We do see something different here because we notice that there is more of a focus on working with students and answering their questions. And so this was very different than what we saw with the science and the technology portions of the STEM subjects. Then finally, we take a look at engineering. We saw the fewest number of post-secondary courses reported for engineering, the majority of teachers just reporting that they only had 0 or 1 courses, and this one course was usually agricultural engineering. It had the lowest overall mean, showing the lowest levels of efficacy, and it had the highest standard deviation, indicating that some teachers felt very good about engineering and some felt very, very poorly towards engineering. Just like with mathematics, we saw more of a focus on working with students and answering student questions. To conclude, overall efficacy was pretty high, especially in science. This is because efficacious people will usually rate their ability higher. Even if they are not effective at teaching it, they will still think that they are doing an effective job. We also saw the statement, "I wonder if I have the skills necessary to teach blank," was consistently lowest ranked for each of the 4 STEM subjects. And in all cases, welcoming and answering students' STEM questions was something that teachers said that they felt very confident in being able to do for all of the subjects. However, we did see a divide between science and technology and engineering and math. With science and technology, teachers said that they were continually improving their understanding of the subject, continually learning and getting better in regards to teaching it. They also said that they had high confidence in their ability to understand and teach the subject material. However, on the engineering and math side, they were more confident in their ability to help struggling students learn the material, and they felt better about their ability to interest students in engineering and mathematics. And they felt that they were able to better explain why experiments worked, and they were more amenable to being evaluated by a colleague when teaching engineering and mathematics. And this is an interesting divide that I feel definitely needs to be looked into more into the future. To make recommendations, we believe that we need to focus more on educators' perceptions of engineering. It is the least understood, least integrated, and area of lowest efficacy for our ag teachers across the board. Engineering and agricultural in agricultural education at secondary and post-secondary levels is important, and teachers need to be able to at least have a basic understanding of what engineering entails and how it is used in agriculture. We also need to explore minorities' experiences with STEM. This subject, or this study, did not have a very diverse participant pool, and so we definitely need to be looking at how minorities have an experience with STEM education and how their competence levels feel. We also need to update agricultural education programs of study in post-secondary courses. Teachers need to be getting a broad overview of STEM fields and not taking as many in-depth courses. So we had 699 science courses versus only 101 engineering courses. And so science is definitely getting the more in-depth study, and we need to make sure that the other areas are getting more of a broad coverage. Teachers need to have basic engineering and mathematics courses related to agriculture. This does not mean that they should completely ignore science and technology, but I think we need to have more of a focus on engineering and math. And we also need to be teaching basic STEM principles and teaching methods. So several universities out there currently have a STEM course for either undergraduate or graduate students. And I think that this needs to be included into more teacher preparation programs.